Hello! Today I'm going to be going through a brief introduction to a piece of software I use quite a lot called Firecapture, which is a free piece of software available from firecapture.wonderplanets.de, basically for the capture of video for planetary imaging purposes, using webcams or dedicated planetary imaging cameras like the one I'm going to be using here. This is a ZW Optics ASI 120MC, so it's a lovely little device. At the moment, I've got 150-degree all sky camera attached, just for purposes of getting an image for preview purposes. But generally that would be attached to the T-thread on the back of my scope, or the side of my scope indeed, with the Newtonian, for the purposes of capturing stuff coming through that. So anyway, without further ado, like I said, it's available for free from firecapture.wonderplanets.de, but always remember, people's time goes into making these things, so if you find it useful, please donate to them, or donate to him. The guy who does it is Torsten Edelman. His time and a lot of other people's time in testing and contributing have gone into making this. So give the guy some support, and hopefully he'll carry on developing it for a long time to come. So, okay, without further ado, we have Firecapture installed. So I'll run it for the first time, honestly. Now, basically, the first time you run it, you get this dialog box up. I've unplugged my camera to show you this, because generally, if you've got your camera plugged in, you run it, it will automatically pick up the last thing you selected. So, in my case, it's a ZWO design. I'll plug it in now. And okay. So, you get a bit of a warning with the ASI cameras. I'm not sure if you get it with others, but these little things can push a lot of data through. They can saturate the 480 megabits per second you get on a USB 2 bus to get the maximum frame rate possible. So that can have a heck of a hit on the CPU, especially with a less powerful machine. So you do have the option of dialing back the USB traffic. I'll show you that in a minute, but it's just a little warning. You can click Don't Show Again. So there we go. So there we have it. As you can see, we have 150-degree lens on here. So it's a good little thing for showing you what's going on. Unfortunately, I don't have the scope set up to be able to do it, but I can show you a brief thing in a minute where you can actually simulate it for the purposes of playing around with the settings and stuff like that. So we have the display. This is the main display, which at the moment and by default shows you the entire output of whatever your camera's chucking out. It will always try to get the maximum frames per second it can down the wire. Now this will depend on several things. It will depend on how powerful your machine is, because chucking all that data down the wire and processing it does have quite a hit on the CPU of any machine. Now this that I've got running here is actually a virtual machine running on a Mac, running on a proper computer. So I'm joking, but basically I've done this to be able to do this screencast a lot more easily. I generally run it on this, which is my trusty little netbook. It's only a 1.6 gigahertz Atom processor, but it handles this very well, with a few little caveats that I'll go over in a bit. Basically, you have your, like I said, your main display, and you have various different controls and various different things, and that I'm going to briefly cover. I'm not going to cover everything because this program is very capable. But it also has extremely good documentation, well worth having a read through. So, up here in the camera section, you can turn on your preview, turn off your preview rather, because it's on by default. So we can turn it off, Turn it back on. If you are getting a big hit on your CPU and you want to be doing something else, you can turn off the preview temporarily. Then you have your main sort of control area, which is your gain, your exposure length per frame, and they're the main two things. Your gain and your exposure length. You've got a drop-down box here, which basically allows you to set the range at which this exposure works, which is really handy because generally you'll only want a sort of quite a smallish range of exposures to mess about with. So this means that rather than having a massive range of exposures on this little slider here, which would make it really difficult to get it precise, it enables you to sort of put that down to just a short range, which you can select in the drop down here. Now, what that range is will depend on what camera you're using, how sensitive it is, etc., etc. So, in this case, because I'm using the lens and I'm using it in not daylight, but in a lit room, it means that we have I've used the 5 to 30 milliseconds thing. So there we go. So you can I'm increasing the exposure, which obviously increases the brightness. You've also got your gain, which you can dial up and down. As you may or may not know, the more you rack the gain up, you'll see the noisier it gets. You'll see up here in this area, it's got quite noisy. I don't know if you'll be able to see it with the compression on the video, but it's quite a lot more noisy. If I dial it back down, we lose a lot of the noise. So you want to keep your gain to 50% or below, really, or 50. I don't know, is it percent? 52 anyway. 100 is the maximum. 0 is obviously the minimum. You want to keep it to no more than about 50, otherwise it does tend to get very noisy. So you have up here displayed in the data, you have your frames per second, which at the moment basically is this exposure length, the number of those, so the number of 11.29 milliseconds you get in 1 second. So in theory, 88.58 frames per second is the maximum. The actual frames per second is the quantity of frames per second your particular PC is managing to get down that wire and process. So we are using at the moment the maximum resolution of the camera, and we are getting 27 frames per second generally. It's going up and down a bit because I'm doing things, and so you get spikes in CPU use, which makes the quantity of frames per second go down for a while. The little dialogue that came up during the initial loading when I selected this type of camera was saying about USB bus usage. You have a slider. If you click on this little blue cog here, you can actually select it here as well. You've got USB traffic, and then this slider lets you dial up and down the USB traffic, and this is a percentage of the maximum that it's allowing Firecapture to use. Basically, if you have that set at 100, if you have a very, very powerful computer, if you've got an observatory set up with a very powerful computer with lots of RAM, lots of CPU cores, feel free to stick that up a bit higher. I tend to keep it to 80 or below because I find if I try to saturate that wire, it just starts dropping frames, it starts having problems, you start getting jumpy frames, all sorts of odd stuff happening. So I would say play with that. It's going to be different for different cameras and different setups and stuff. But if you have the ability to do that, it can stabilize an otherwise unstable image. So you have a little box here which is image, and this is actually describing this is the fantastic thing about this this piece of software that, as far as I know, isn't available on things like SharkCap and similar. You have a thing called a region of interest. Now, as you probably know if you've done planetary capture, when you're taking a video, you have vast majority of the image is black, is background. Because cameras like this are transferring the entire image, no matter what's in it, they're not compressing it. The whole idea of these planetary cameras, these dedicated planetary cameras, is that they send the image down the wire without compressing it, so you're not losing any detail. This is why if you use a webcam, you can get very high frame rates, but what you'll find is it effectively wipes out all the detail. But you don't get this massive CPU use, and that's because it's compressed. What's coming down the wire, despite being 60, 70, 80 frames per second or whatever, it's compressed so much that you lose all that detail. And these dedicated planetary cameras don't do that, with the side effect that they need a lot more in the way of CPU and USB bandwidth to do their job properly. So, what this little section here, the image section, allows you to do is say, I'm only interested in this small area in the centre of the chip. So you can define the size. I mean, there's a little dialog box. If you hover, this happens in a few sections of this program. If you hover over the thing, you can either let's have a look. I believe you can type in direct. Let's have a look. No, you can't. There we go. So you click this little down arrow here. It's not the most intuitive thing I've ever seen, but found it reasonably quickly. There we go, and that gives you a list of resolutions. Now, what a lot of programs do is when you select a lower resolution to use, rather than taking a sort of region of interest like is being described here, it actually takes the entire image and just makes the resolution smaller. So your object doesn't appear any bigger on the... your object still takes up the same amount of space in the frame, but it's lower resolution. Now that's completely useless for the sake of planetary imaging, because you want that planet to cover as many pixels as possible, which gives you the detail. So what this does, if you select the region of interest, so if I set use ROI, bang, it's taken effectively the central 232 by 256 pixels, and it's only capturing those. Now, what you've got to note here is, look what's happened to the frames per second. It's gone up to effectively, in fact, actually slightly over the maximum. I'm not quite sure why that happens, but it does. So that is now able to capture 88 frames per second. And it will only be capturing, if we had a planet on here, it would only be capturing the part you're interested in, which is the planet itself. So if I take that back up to maximum, that'll drop back down to 27 frames per second. Now, if you've got an extreme, very good scope, and you can get a nice big image of the planet on the middle, then you obviously won't want to take it as far down as 232 by 256. But you can define here what you want it to be. It doesn't matter, and it will only capture that. That is the wonderful thing about this. And now I'm not sure whether this is available, I must admit, on all cameras. It is available on this particular one. This camera itself is actually functionally very similar to the QHY52 or QHY52L or QHY5L2. You know what I mean. It's basically the same chip, so I believe you get the same functionality on that. But this region of interest thing is the thing about this program that I absolutely love. So anyway, I've evangelised about that enough, so we'll move on to the next bit. You have the capture box here. Now, in here you can actually set up profiles. Now, this is another wonderful little thing. You can set up profiles per planet, which can have different settings. So for example, different settings for the region of interest, because of course the region of interest for Jupiter is going to be bigger than the one for Mars. And you don't really want to be messing about with these settings every time, so you can actually save them. And if I move to Jupiter, you'll see my region of interest is bigger. It's 336 by 384. My exposure has changed. I'm not sure whether this is correct, because this isn't my capture PC, but you know, you can set different settings for each planet, and you just switch between them on here. So Saturn, there we go. It's slightly different again. It's actually, you notice that the default is a little bit wider there, probably to get the rings in. But yeah, it's basically you can set profiles. Brilliant, absolutely fantastic. Now to capture, all you have to do is click Start Capture. There we go. And that's started. Now it will constantly tell you how big the file is you've captured so far, how many frames per second you're getting with your current settings, and you know that's it. You leave it going for as long as you want to, and you can stop it. Now you have the option here to limit it. Oh, by the way, you set your capture type in here, which I always set to API, but you can set capture in individual bitmaps or fit files, you know, however you want to do it. But I always prefer to do it via API because it's one file, a lot easier. And once you've done the capture, you will find it will appear in in this little. That's brought up the actual folder with the capture in, which is great. That's that little button there. You can dispose of the last capture by clicking that. So if you know you've got a bad capture, you just click that. And then you can set up your capture folder in there as well. But here, this wonderful little thing, you have a session browser. This tells you, this constantly updates with a list of all the captures you've done in this session. You can open a full session browser, which gives you all the captures you've done full stop. Here you've got your individual captures, which you can actually double click and bring up a full page, which you can actually save out as a text file for the purposes of sort of archiving your settings for a particular capture or something like that, if you want it there. It gives you loads of information, things like the diameter of the object, the magnitude and stuff like that. I'm not sure where it gets that from. Must admit I'm not totally sure, but it's correct. Let's put it like that. So close that. So what you'll notice actually is the histogram has come up. The histogram is great because it's difficult to illustrate here, but it does actually allow you to set your exposure and gain quite accurately, because what you want to have is a histogram that stretches most of the way across that image, because that tells you you've got a range of tones which covers from black through the different ranges through to white, which is the best situation. So if I increase, I'll do it by increasing the gain in this. There we go. In this particular case, but what you want is a decent histogram. It won't be this shape with the planet; it'll be slightly different. But you know, you get the general idea. It means it takes a bit more of the guesswork out of setting the exposure. So you can do that by doing that. You can set it using the exposure, but obviously the longer you make your exposures, the fewer frames per second you get. Now we're still getting 79, so you know that's perfectly adequate. If you can avoid taking the gain up, all the better. So, okay, we have, by the way, you can limit your exposure either by seconds or frames or minutes or by file size. I tend to do it by frames. I like to capture, I don't know if this is too many, but I seem to get decent results. I like to capture about 8,000 frames, for example, if I'm doing Jupiter. And I tend to end up using about 4,000 of those to stack. So yeah, so that's a good way of limiting. It means you don't have to be there and clicking, you know, to click stop once you reach the relevant amount of frames. So moving over to the options section, we can turn the histogram off and on, which is good. Once you've set your exposure and you're happy with it, you can turn it off if it's annoying for the sake of for the purposes of focusing, etc. You've got the ephemeris, which will show you various information. It tells you how wide the planet is at the moment, its magnitude, and various other information. Tells you the focal length. I'm not quite sure how it works this out, I must admit. I think it might be doing it. Obviously I can't do it from here, there's no planet on there, but I think it might actually be doing it from the image itself. So it figures it out, basically, works out how wide it is, what the focal length is, and it knows, because of the camera, you selected the camera, it knows the size of the pixels, so it can figure out the focal length you're using, which is quite clever. So you have various other options on here. One of them is debayer. Now, this is something which on my, I'll put it back to maximum resolution, on my little Atom source remote, my little netbook, it's not a particularly powerful machine, and as I said, this can quite easily saturate the bandwidth on the USB. Now, you do that on a less powerful machine and it struggles, which will in turn make the frame rate drop. So what you can do is get the camera itself to send the raw data, rather than, well, it's sending the raw data anyway. Whatever happens, it's sending the same data across the wire. But at the moment, you'll see it's black and white. It's a colour camera. I mean, it's there. It's a 120 MC. It's a colour camera. Why is it black and white? Well, the reason why is because it's sending the raw data, and basically the computer itself is not doing a process called debayering in real time, which means it appears black and white. Debayering is a process of applying algorithms to the image to turn it from this black and white raw image into the colour image you expect to see. The thing about this is it requires CPU. Now, if you decide to do this, if you click debayer, you all of a sudden got a colour image. Fantastic. But what you'll notice, actually, on this, it's not making too much of a difference at the moment. Oh, a little bit, but it's on my netbook. If I put it into colour, it is dropping every now and then. But if I put it into colour, if I debayer it in real time on my netbook, the frame rate drops from, it drops by about 3/4. So basically, this enables you to, because what you're asking it to, you're saying, take this raw image, take this raw data flow, and turn it into colour in real time. It doesn't matter. You don't need it. When you're doing this, you can do it. You can do all that post-processing after. You can do that in post-processing afterwards. So there is no need to do this in real time. So I would suggest untick that, capture the raw data, let whatever stacking program you use, Registax, Auto Stack It, anything like that, do the work for you afterwards. Capture in RAW. That's the way I do it anyway. You have various other things here. A particularly cracking little feature is auto align. Now, what this does is if you've got bad seeing and your planet's wobbling around all over the place, auto align will attempt to correct the framing of it to keep the planets in the middle of the frame. It works very, very well. I haven't really tried to capture with it yet, but I would have thought the thing it's most useful for is during focusing. Especially if you don't have a Bart enough mask for doing your focusing, if you're trying to focus on the planet itself, if it's jumping around, it's really difficult to see properly what's going on. With bad seeing, it's hard enough anyway. But yeah, it's not an easy process focusing. So auto align gives you stability when you're doing it. I'll show you in a minute. I'll put that you can do a simulation on here. I'll show you how it works. You've also got things like you can enable a reticle for doing your go-to alignment. If you want to do your go-to alignment, you can actually use this to do that. You've got a focus help button, which impossible to show you here, but basically brings up your focus as a percentage, which once you click it, you basically focus, and what you've got to do is try and get this sharpness compared to start as high as possible. So you want it at least 100%, because if you're perfectly focused when you switch it on, you'll never get over 100%. So you focus it until you have the highest percentage possible. It's not bad, it's certainly pretty good, but to be honest, I tend to do it with a Bartonov mask anyway, because I find that's by far the most accurate way of doing it on the planetary stuff anyway. You can take a dark frame. Obviously I'm not going to do it now, but if you find, especially if you find you've got a very noisy image, you can take a dark frame, which will help to cut out any hot pixels or anything similar. You've got to cover the scope, click OK, it'll take the dark frame, you remove the cover from the scope, and it subtracts it. Can clean up your image, but to be honest, this little camera is pretty good anyway. It's pretty low noise anyway. So especially in the length, the length of exposures you're doing. I mean, this is like 12.55 milliseconds. Noise is negligible. So it's fine. It's fine. Cancel that. You can flip X, flip Y. You can make it easier for if you're trying to center it with a hand controller and it's going the opposite directions to what you expect. You can flip it either in X or Y to enable it, to make it easier to do that. So anyway, yes, you've got the zoom options. You can take the zoom down. Now, the reason that's useful is I've got a big maximum resolution here. It doesn't fit on screen. So if I take it down to 50%, you've now got your entire image on screen. You can use it to centralize your planet. So the way I would do this, I'd bring it up, focus it, centralize my planet with it zoomed 50%, especially on my netbook. It's a much lower resolution screen, and then I would switch to the region of interest, which is the center of the frame, and switch back to 100%, and I'm ready to capture. Like I said, open it up, have your big image open at 50% zoom, and what you've got to remember is this zoom is only applying it to what appears on screen. This doesn't actually affect what's captured at all. This is just zooming in and out to enable you to fit your entire image on screen. It will always capture, even if it doesn't fit at all on screen. So if I switch back to 100%, you'll notice you've got scroll bars. It will always capture the entire image, whatever happens. So that's fine. Or it'll always capture whatever you've got selected here, either your region of interest or your maximum resolution. So 50%, center your image, go to your region of interest, switch back to 100%. You're ready to go. Now, pre-processing, I haven't done much here. I will I will have a bit of an experiment over the next few weeks with this, but at the moment I don't really use any of this. Anybody who does, please let me know in the comments. It might be handy to know. Next, you have your settings section. Now, this is basically a quick access to all the most common settings areas in the program. This program is incredibly configurable. Generally, you'll find the default stuff is pretty good. I haven't had to change much at all, but obviously, tweak it, have a mess about, see what you can do. But generally, I found the default settings are pretty good. You got things like auto guide. You can actually auto guide using the image. You can control the mount from the same program, and cause it to keep the image of the, if your tracking is really bad, cause it to, you know, work to keep the image of the planet central on the chip, which is kind of cool. I've never done it, but it's possible. Right, next thing I'm going to do is fire it up quickly in simulation mode. If I start Firecapture without the camera attached, and then select the camera, select the camera, okay. It'll tell me it can't connect, couldn't be started. Would you like to see some tips? No. What next? Play with dummy cam. What this enables you to do is play with the simulated input, which is great. Lets you play with a few of the settings. Not all of them work, but it gives you a good idea of what's going on, and with several different planets as well. So if I'm actually going to switch to Mars in this case. There we go. The reason why I switched to this is because it has this wonderful bounce. I mean, obviously, you're not going to get a lovely regular bounce like this. It looks like a little ball bouncing on the ground there, but you don't get it quite like that. But you know, it can quite often be this unstable when you're actually capturing. So this gives a good opportunity to play with the auto align. So if I click auto align, straight away it stabilises the image. Now, it will actually capture it stabilised as well, which is really good. But this I find is absolutely brilliant, like I said before, for focusing. So very, very useful. You also have, you can start focus help. Now, again, this is giving you you know, very regular cycling because it's only a short clip which is being constantly cycled, but gives you an idea of what it would look like in a real situation. So yeah, it's a very handy little feature. This, you know, flip X, flip Y, you know, whatever you need to do. You kind of mess about, zoom, give you an idea. But basically, what it does is give you an idea of what it would look like in a real situation. So you can also change to Saturn. There we go. Do auto align again. Fantastic. Stops it dead. Brilliant. Anyway, that's enough of that. So yeah, I mean, this has been a sort of brief intro to Firecapture. It's been a little sort of informal and a little sort of all over the place, but hopefully it's been useful to you. But any questions, let me know and I'll do my best to answer them. Thanks.